Hi class, how are you today? Well, that's simply not rational. The learning target for today is to be able to simplify rational expressions. For the scale, you're a 3 if you can simplify rational expressions. You're a 2 if you can simplify rational expressions if the GCF is a monomial. You're a 1 if you can simplify rational expressions if they're fully factored. So if the rational expressions are already fully factored, then you can cancel stuff out and simplify it that way. Or you're a 0 if you cannot simplify any rational expressions, whether they're fully factored, have a GCF that's a monomial, or any others. Let's get started. All right. So here they want you to simplify the rational expressions and state the excluded values. I'll get to the excluded values in a moment. But first, let's simplify this first expression. This is one we've already covered before. You just divide the coefficients and then subtract the exponents for the variables. So 12 over 32, you can reduce that. 12 over 32, 12 and 32 can both be divided by 4. 12 divided by 4 is 3. And 32 divided by 4 is 8. And then n over n squared. Well, n over n squared, remember we say there's a 1 here. 1 minus 2 is negative 1. So it's an n to the first, or just n, on bottom. So that would be your answer, 3 over 8n. However, there are excluded values, because that would work, except what happens if we plug in 0 into that? If we plug in 0 into this equation, well, up top would be 0. 12 times 0 is 0. But on bottom would be 0 as well. 32 times 0 squared is 0. 0 times 32 is 0. We're dividing by 0. We can't divide by 0. That doesn't work. So you can't divide by 0, so we have an excluded value. This simplification doesn't work when n is 0. So we have to state that that's the answer when n is not equal to 0. And this is our full answer. All right, for this next one, we've done ones like this before too, and there's a couple different ways you can do it, but I'm going to actually just factor it out because this section is all about factoring. So if you can see it by factoring, it'll make everything make more sense. You could do this without factoring, but I'm going to show you how to do it specifically with factoring. So up top, we can factor out a GCF. So 14x minus 10, that has a GCF of 2. So we can factor out a 2, and then what's left inside, 14x divided by 2 is 7x, and negative 10 divided by 2 is negative 5, or minus 5, and still over 12. Now, 2 over 12 can reduce, so you can divide them both by 2. 2 divided by 2 is 1, so we're left with just 7x minus 5. And on the bottom, 12 divided by 2 is 6. And that's as fully simplified as that can go. And then we have to look at the excluded values. Well, the denominator at the very beginning, you always have to look back at the beginning of the problem, is 12. And no matter what we put in for x, everything's going to work because we're not dividing by 0. So there actually are no excluded values on this one. So this is our answer. All right, so now we are going to simplify. All right, so now we have two more examples, And we've got the same rules. We're still simplifying rational expressions and stating the excluded values, but this time we're factoring quadratics. And so those are usually a little bit more difficult to factor, and so it might take a little bit longer, and these are usually the ones that are considered the harder ones. So, for the first one, if you remember how to factor when a equals 1, there's no number in front of the x squared, we're going to factor these. So, for 6, what two numbers multiply to 6 that add to 5? That would be 2 and 3. So we're going to do x plus 2, x plus 3. And then in the denominator, what two numbers multiply to negative 21 that add to negative 4? That would be negative 7 and positive 3. So x minus 7, x plus 3. And notice we have an x plus 3 in both the numerator and the denominator, so those can cancel out to leave just x plus 2 over x minus 7. Now, we still have to have excluded values, though, and we have to go back at the beginning, but we can look at the factored form because that's easier to figure out. So, when do we divide by 0? Well, we could divide by 0 when x is 7, because 7 minus 7 is 0, and 0 times anything is 0. And also when x is negative 3. Negative 3 plus 3 is 0, 0 times anything is 0. So we have to state that the answer is x plus 2 over x minus 7 when x is not equal to 7 or negative 3. And this is our full answer. All right, and on the next one, in the first one I didn't mention about common factoring, but remember you should always start to see if there's common factors you can take out. They'll always make everything easier. So on the numerator, the common factor we can take out is 6x. So we take out 6x. And then left in the parentheses would be x plus 2. And then in the denominator, we can factor out 5. And left inside the parentheses is x squared plus 4x plus 4. Now, because we did that, that makes the denominator easier to factor because a is 1. And so the numerator is going to stay the same. But the denominator is going to be 5 times, and then what two numbers multiply to 4 that add to 4? That would be 2 and 2. So we've got x plus 2, and we could say x plus 2 times x plus 2, or just x plus 2 squared. Either works, whichever you prefer, but either way, notice there's an x plus 2 on top and on bottom, so the x plus 2's cancel. So on top we have 6x, and on the bottom we have 5 times x plus 2. We had x plus 2 squared, so that means we have 2 x plus 2's, only one of them end up canceling. So we're still left with an x plus 2. So now this is fully simplified in factored form. However, I usually prefer to have it so it's not in factored form. It's not fully simplified if it's in factored form. So we're going to keep going, and since there's no more simplification that can be done, we're just left with 6x over, and then we distribute the 5 back in. 5 times x is 5x, and 5 times 2 is 10. and so we're left with 6x over 5x plus 10. However, we still need to do the excluded values, so we go back and notice that we had 2x plus 2's, so that's when x being -2 would give us 0. You don't have to state it twice, even though there's 2 of them. It repeats, you only have to put it once. So when x is not equal to -2. And this is our full answer. All right, now time for the sponge activity. Same thing we just did in the video. I want you to simplify the rational expressions and state the excluded values. For number 1, we have 42 n to the 6th over 12 n to the 4th. For number 2, we have 7x minus 70 over x minus 10. And for number 3, we have v squared minus 20v plus 100 over v squared minus 4v minus 60. So simplify them as much as they can be and state the excluded values. All right, that's it for this lesson. Once again, please make sure to take notes on the entire video. Take a picture of everything, including the sponge activity. Submit it all to Doodle Classroom, and have a good night.